Hello, I'm SIANG. I'm a student from degree in Science in the Chemistry Industrial. Today I will have a video about usage of GCMS in dairy industrial. So firstly, what is GCMS? GCMS is an analytical instrument combination of gas chromatography and mass spectrometry specifically used to detect a compound in volatile sample. Be- Because of gas chromatography, the sample of insert into this instrumental must be volatile, can become gas in in high temperature of 100. So why we use GCMS in the dairy industry? In milk, there are several volatile and semi-volatile compounds. Be- Then if we want to use identify them, we use gas chromatography to separate each of the compound into their individual. Then we use mass spectrometry to identify the compound. So which compound in milk can be analyzed using a GCMS? In the screen, we have the lauric acid, stearic acid, tocopherol, sterol, and others. Most of some of the organic compounds are used to analyze in the separate in the chromatography and analyze using the mass spectrometry to find the concentration and also its properties in ionization or physical and chemical properties. So how gas chromatography works? Compounds in milk samples are separated by their difference in vapor pressure. Some of the compounds may become vapor quickly because of their light molecule structure, or they have the low interaction between the mobile and stationary phase in the chromatography. If they have strong mobile interaction with mobile and stationary phase, they should elute slowly and have high retention time. Then, after we have phase for know the use of gas chromatography, we look into their main component for GCMS. It must have a mobile phase and stationary phase, which the mobile phase move the analyte into the column and it developing them to separate. After that, elute the analyte from stationary phase to the waste. Then in stationary phase, we have the coated of some silica gel for the polar surface, or we have the non-polar surface, which it can retain and bond with or interaction with the analyte to retain them for separation with other compound. So in other component of GCMS, we have the injector, which we can inject the sample, or we have the pressure regulator, which control the pressure of gas into the system. We also have the flow controller, which we need to control the flow of gas into the column. To get the better resolution, we need to control the flow rate to the specifically. Then other than that, we have the oven also, which the oven will hit the column to make the flow fast. Then how about the mass spectrometry, which the mass spectrometry ionize the separated compound from the gas chromatography and identified by its molecule structure. By using the ionize the analyte, we can obtain the difference between the molecule. Like some protein have the heavy molecule, they will move further and slower. If, and in some fat may move faster because of its low molecular structure, and even the virus in the milk we can also can be identified in the mass. So the main component in mass spectrometry, we have the vacuum system, which create a vacuum to prevent the disturbing of several compound. And we have the mass analyzer, which analyze the mass of ion pass through the detector. And we have the ion source, which create the electron bonding or chemical ionization to the analyte, so we can obtain the ion and know their. So in milk, we have the two type of analysis in mass spectrometry. One of it is full scan mass spectrometry. We analyze all the compound in illude. These methods are not performly in routine check because it is very taking the long time and very long procedure because it used to have a wide range of detection for each compound in the milk in the analyte or sample. So it's mostly used in the development to know all the compound that may come out in this research. For the selected ion monitor is mostly used in routine check, which we scan only one compound or some selected compound to know their properties. Okay, so how do the GCMS involve in research and development in dairy industry? When we take a new product, we have to know the properties, the characterization, and their identity of the new compound. If not, we may obtain different compound at the repeating development. So we need to characterize so that we can know their condition and know the final product of the development, so we can repeat again the experiment to obtain same the development of the process to obtain another new compound. Okay. When do GCMS used in dairy industry? Most of the time, other than the research and development, we use the GCMS to do the routine check, which we selected only a few compounds like the pesticide or other the stearic acid, the fatty acid, and also tocopherol, which we check the milk sample of their quality during the pasteurizing of milk. We heated the milk, we don't want the nutritional to degrade, so we use the GCMS to check each of the important nutrient to prevent their degradation. Then it is used also to ensure the consistent quality. We don't want the quality become fractured, so it is important to use the GCMS to know the quality of the process and find the defect occur at the process, so we can to prevent and cure the defect in the process. This is the data we obtain from the GCMS. If I is the chroma like the graph, and it has many peaks. Each individual peak represent individual compounds. So from the peak we can know the broad, so we can identify the concentration of each compounds in the sample. So the key of identification for each compound is their retention time. Each compound have the specifically of their retention time. If have the better resolution, we should take a sharp peak for each of the compound. Okay, why this data are important? Why we need those peak? Some peak may represent the pesticide that may occur in our milk. Because in the food regulation, the composition of the toxically product should be below than a specific amount in a very small amount. So we need the data to identify the harmful substance that may occur in our sample or our milk to ensure there are no toxic hazardous compound in our sample. So other than that, we analyze and provide the detail about the identity of pesticide, so we can know where the pesticide is come from, and try to prevent another round of the or to lowering the absorption of pesticide into our milk. Okay, then after that we can also to do the fatty acid analysis, which we fatty acid is the main component in the milk. If we want to know the quality of milk, which is the milk is nutritional or unnutritional, the fatty acid analysis is the important role in identifying whether the milk is nutritional. So there are a few predominant fatty acids, such as the saturated fatty acid. We have stearic acid, C16, palmitic acid, C18, myristic acid, C14, or we can also have the unsaturated fatty acid, C18 linolenic acid, but you have the unsaturated double bond. So it is the main component in the milk to know that whether the milk is better to drink or is used to make the butter because it highly in fat, solid fat. And the last data important, we have the volatile compound analysis, because some of the milk they are used to make the butter or ghee through the ripening process. So in whether when we know whether the flavor are developing or not, the volatile compound need to analyze to know their properties and know their condition in manufacturing and storage. So we can the individual of the flavor compound are volatile, so they can test at the GCMS and separate individual. So at the last part is important. It also used to detect the adulteration, because in now in the market there are very more adulteration of the milk, which they use other component like the palm oil or other palmitic oil. Some we also use the non-edible oil like castor oil to adulterate the good oil like the butter or olive oil. But most importantly, in the dairy product, the fatty acid represent the quality of the product. So we can identify the fatty acid to know the authentication of milk fat in the method of processing. Also, their sterol and tocopherol amount in the milk to know their adulteration. So we jump to the conclusion. GCMS is very important in dairy industry because they help developing new compound. After we know the creating a compound, we need to know their properties and their identity. So we don't want to repeat the all compound again and again. So we can find another new compound and their processing method. And secondly, GCMS also help in control the quality of product. Through the analysis of fatty acid, we can know whether the milk is good or bad, or is nutritional or unnutritional. So they give the detail of compound in the product through the mass spectrometry. We can know the detail of compound through their molecule weight. Okay, that's all. Thank you for listening.